and I'm following straight on from tutorial 10 where we'd actually sort of just done a very basic room and we'd made a calculation on it. Note I've just sort of gone back in there and I've basically done a full calc and I've also done the daylight factor calc, so we have a full range of values and just to totally refresh you, very quickly, and I was showing you how these like annual daylight illuminance files are the illuminance values for every hour for every point of the year. So I guess that means what we got, like maybe 20 calculation points there. Yeah, those are the values at January the 1st at half 8, 50 lux, 67 lux, 49 lux, etc., across all these points. And it is literally doing that for all of the year. That's August 14th, half 4, yeah, 1123 lux, etc. I didn't, you wouldn't have seen the daylight factor calc. It's a much more manageable file, and it's just sort of like it's all these calculation points just listed down here. So 5.9%, 8.4%, etc. But again, so we basically all we did was just calculate and put them in a list. That's not useful data, is it? So what we need to do is we need to format it into something more useful. And with climate-based daylight modeling, I'm not that interested in daylight factor because you'll either know it, and I've already suggested if you're only interested in daylight factor, you are not in the right place. Um, I use Relux for daylight factor with the ray trace with the ray tracer, not the radiosity method. Um, Okay, if you go to get results here, what I've got here is the thing is with the client-based with the annual luminance data is there is so much stuff you can do with it. You can go off and do your own stuff. You could get like dimming profiles for lighting. You could use the sunlight stuff to ask a few very simple questions about glare. What else can you do? I mean, if you can sort of accumulate, you can get cumulative data from this one and work out lux hours if it's a museum. But I think most of you, what you're going to want to do is say, I'm doing climate-based daylight modeling because I have to, because BREEAM says I have to, because the Education Skills Funding Authority says I have to, because LEED says I have to, right? So and so what I've done is these nodes here, they format that raw data into the data you need to know how does it perform against these standards. If you're just, if perhaps like me, you're like, wow, this client-based data mining, it is really useful data, and I was never really on board with daylight factor anyway. Well, you can just there is the useful daylight illuminance, and there is the uh, well, there's daylight autonomy. I'm not so much of a fan of that one, but yeah, you'll need to Google that to figure it out. It's beyond the scope of this one, but I think mostly you're going to be using BREEAM, aren't you? So this is the BREEAM node. It asks the question, how does this data perform against these BREEAM standards? So and can you see here all these values, right? They all have defaults. Remember, the dash means they have default values. These are the BREEAM defaults. So if you just leave them, it will do you a BREEAM analysis. So I'm just going to plug that in, and I'm going to leave those on defaults. The reason they're kind of exposed is just so it's like, it's done for you. But sometimes you're doing a project where you're like, I cannot get the BREEAM standard, but you can ask what if questions very easily, but what if my targeted illuminance wasn't 300? What if it was 200? You can at least ask that question. If you don't want to, well, then just leave it alone. You've got both options there. Um, Boolean, false, and yeah, just run the calc. Yeah, it's done. So things get a lot quicker on this side because the lion's share was done over here, and I haven't taken so much time, have I? So I can I'll just very quickly show you what did that actually do. Uh, Helpful. Open file or folder. So when you go here, so basically BREEAM, it says you can get your results via, you need an average value, you need a minimum value, or you can get it from the daylight factor method. And to be honest, that is one of the major reasons why daylight factor is even in this this calculation. Open file or folder. Did it open it? Let me shuttle that down. Yeah, okay. Yeah, so it's just written this file here, and it's and rather than all those other figures, it's kind of yeah, it's written all these bits and pieces here. It's in this format. It's still not quite ready, is it, for client submission or basically for you to understand what's going on. But it's the same like with the daylight factor. It's the same. Actually, up here is the true value. Down here is the color value, which is useful for the next node, and summary values at the top. And I mean, I think you can figure this out, but I'll show you anyway. Oh, show you anyway. What do you want here? Lead results. Let's say. So lead is the American equivalent of BREEAM. I'm sure you all knew that anyway, but. Oh, I'm trying to plug BREEAM into lead. No, that doesn't work, does it? Right. So then you can go plug that in, and you see that you need the sun. They use the sunlight method. Um, Very questionable. If you read research papers on this, very questionable methodology. But if you have a project that needs it, then you've got to do it, haven't you? Yep. It's exactly the same thing, just comes out the other side, yeah? Annual sun exposure, daylight autonomy. Exactly the same stuff. So we're almost at the end now. So we did the kind of the raw calculations. We've processed that data. Now we're just going to move on to the display results right at the end. Thanks for bearing with me. We're almost through it all. I'm going to just close this off and start a fresh one.